Now recording. Is that gonna? That'll be good. Good. All right. So, your question, if I'm getting your question correctly, in assignment 3, there's a requirement that you use JSON encoding to send information from the server to the client. What is the advantage of doing that versus plain text? Right? Well, basically it solves the problem of parsing for you, right? So let's imagine, rather than sending it as a JSON, let's say we had information that we needed to send, like name is Nick, age is 36, occupation is know-it-all, right? If I wanted to send this data from the client to the server, there are basically two, I'll do it here so that the camera can see it as well. There's the plain text approach, and then there's sending it as a JSON, right? So if you decided to do a plain text version, the first problem you encounter is that you, personally, are deciding on how the encoding should look. Now, this is fine if you're the only person ever to work on it, but because you're not working with a standardized format, other developers who might be working on your project may have a difficult time understanding how you're encoding your damn packets, right? But you could do like some kind of relatively, you guys heard that beeping, right? I think it's the garbage truck. Yeah. Anyway, you could do a relatively straightforward encoding, you know, inside of your packet, which you can think of as a file or a string. You could say something like, you know, name equals Nick, you know, age is equal to 36, et cetera, et cetera. You could just like drop that in, throw new lines or throw commas in as separators, whatever you want, right? You could do it that way. The trick is, if you do it that way, not only do you have to write code which composes this packet on the server side, you must write code which decomposes the packet on the client side. So the client has to be able, the client has to know that these are key value pairs, right? Another way of doing it is you could just drop the data in. Nick, 36, you know it all. Right? If you did this, basically what you're doing is you're hiding secrets inside of the data. The client has to just know that this argument is intended as a name, this argument is intended as an age, and this argument is intended as an occupation, because it's no longer labeled data, although it does make the packet a bit smaller, right? So both of these are plain text approaches that would work, right? The trick is, if you use JSON to do the same thing, first of all, it's still very readable, right? Name is Nick. Age is 36, and et cetera, right? It's still very readable if you had to like poke around inside the data. But because it has been placed inside of a standardized format, you know, every programming language in existence has a JSON decoder, right? Or at least if it doesn't, it should. So this packet, once received by the client, it's a very simple one-line thing to turn a string encoded like this into an equivalent data object in JavaScript, either a dictionary. Sorry, that's Python terminology. They call them objects and arrays. You know, some combination of an array and object. In this case, it's just an object, just a plain old object, right? So, because it's in that standardized format, it can be read and decomposed without you having to do hardly any work at all. And that's the primary advantage of it, is that it automates a lot of this process. Because otherwise, like, let's think for a moment, what would the process be if we wanted to write an algorithm ourselves that parsed JSON, right? We would need to have loops that trace through, looking for curly braces. Okay, that's the start of an object, create new object, you know, trace it until you find a comma, right? Then trace back until you find the colon. Take this, remove the quotes, set that as key, take this, remove the quotes, set that as value, write that into the object, repeat to the next line. It's a whole procedure, and it'll do it for you if you let it. Does that answer your question?
Thanks, Dr. Ward.
No trouble.
Makes sense.
Yeah. I know that, like, all of this stuff does feel a bit painful, but a lot of work has gone into making it as unpainful as possible. You know, unpainful may not be a word. It's okay. Because, like, the absence of pain, we don't really consider it to be a state. You know, we say we're feeling in a particular way, and the implication is that we are existing in the absence of pain, but we don't really have a word for the absence of pain. You know, maybe we should invent one. Yeah, like most people say they're feeling fine, right? If they're not in pain, but like that's not what that word "fine" means, actually. You know. Anyway.
Can I just ask one more question, Dr. Ward?
Absolutely.
Also, with that assignment, I combined. I don't want to use the word combined. I put the PHP and the HTML in the same PHP file.
Yes. This is fine.
Perfect.
Yep. It works, right? You tested it? Then that's good. Yeah.
That took me a while too.
Yeah.
Because the assignment didn't mention anything about an HTML file. I'm like, okay, well, just put it in here.
Yeah.
Okay.
Well, that's the beautiful thing about PHP is that opening PHP tag can, like, we haven't talked about this so much yet, but we will get to this this type of material once we start talking about MVC architecture, which I think is next week. But yeah, basically, you can have multiple PHP tags, but the PHP scripts themselves are kind of, it seems derogatory to call them like parasites on a HTML file, but like they are a thing which is embedded in HTML. Because we've only been learning PHP and we've been trying to get those skills, you know, we need to get some ground level stuff established in PHP. We haven't really been like doing a lot of integration with HTML and the other stuff, but here's a fun fact, right? What PHP does is it writes strings into an HTML file. One of the things that you can write into an HTML file is JavaScript. So you can actually use PHP to manipulate JavaScript as well as HTML. This is what we call meta-programming, because we're using programming code to generate or modify programming code. But, you know, that's a fairly advanced thing. It's cool that it exists, but I'm never going to expect you to actually use it, right? I feel it's important to know how cool things are, really. So, I'd like to introduce assignment 3. You know, for the benefit of 3/4 of the class who have not yet submitted anything for it. So, assignment 3 is a patient back-end form validation. Create a web application that allows for patient data entry with back-end form validation done with PHP. So this is a little bit different from assignment 2 in flavor. In assignment 2, we used the front end and JavaScript to perform a certain amount of validation and a certain amount of processing based on form entries from the user. Here, we are going to perform similar work, but rather than having that on the client side in JavaScript, we are going to do that on the back end, on the server side, with PHP. So, you will create a file called patient.php that, when placed in the htdocs folder of XAMPP, can be loaded in the browser at the URL localhost patient.php. When the web application is first loaded, the form should appear on the page with the following inputs. In addition to a submit button and a random button, the validation requirement for each input is also given. So, you've got a submit button and you've got a random button, but you also have the following form elements. First, a first name, which must be made of letters and be between 2 and 20 characters. A last name with the same requirements. A health card number, which must be of the format given here, XXX-XXX-XXX space AA, where X characters are digits from 0 to 9 and AA are letters from A to Z. You have a couple of helper links to some PHP functions which can help with those processes. C-type digit checks if all of the characters in a provided string are numeric, and C-type alpha, which tells you if they are alphabetic. So if you use these as your Boolean tests for these characters, you can see whether or not you are conforming to this standard format. Finally, date of birth. You are to use an HTML date picker as the form element, link provided, and the date year must be before the current year. So, whoa. Oh man. Kevin. Everyone knows you don't refer to the current year inside of an assignment document because then it has to be updated every year. That's okay. I do like how many references to documentation this assignment description contains. That helps a lot. Use Bootstrap to style the form, please. When the submit button is clicked, the data in the form should be sent to the same PHP script called patient.php as part of an HTTP post request. Why is it a post request?
Because of privacy.
Because of privacy, yes. We don't want to transmit name, date of birth, and health card number inside of the URL in a publicly visible way. We want that information to be private because it is private. So we send via post request. And, I've said it before in this class, but since all of you are, targeting employment in the healthcare sector, shall we say, the healthcare sector has more stringent privacy concerns and regulations than many other sectors. So like if you take nothing else from this class, use post, not get, whenever you're dealing with anything sensitive. Hopefully you take more from this class. So, when the form is submitted and one or more validation errors exist, display an unordered list of the errors that occurred below the form. For example, the last name must be between 2 and 20 characters in length, and healthcare number format invalid. So, unordered list is HTML speak for a bulleted list, right? So basically, you want to, this is what you want to do, right? All of your validation checks will be a series of if statements, right? These if statements, in the case where the validation check fails, the if statement should write some bullet point into the HTML file that contains some kind of useful error message, specifically which condition has been violated. Does that make sense? So far, so good? So, when the form is submitted and no validation errors occur, the message patient data entered correctly should be displayed below the form. If the random button is clicked, an AJAX request should take place to the script random.php. Download the existing script, do not write your own. The script will return a random first name, last name, and health card number and birth date. Use jQuery to set the form inputs to the values provided by this script. So that is, that's like a part 2 to the assignment, but probably you spent more time on part 1, right? This is not so very different from the work that you were doing in the last assignment. The whole point of that, the whole point of this part is, okay, so you know some JavaScript. Can you create an AJAX request? And can you receive the data from an AJAX request? Submit your solution in a zip file called as3.zip. The instructor will unzip your solution and copy your files into the htdocs folder on their computer to run your application. Sehr gut, ja? Mark breakdown as given. So in this case, you'll see that it is specifically requesting you to use jQuery to set the form inputs. Use jQuery to set the form inputs. So while it's possible to do this in vanilla JavaScript, you are not fully meeting the requirements of the assignment if you don't use jQuery in this case. Does that make sense? You'll also notice that you have some marks given here for Bootstrap styling. So, basically if you didn't use Bootstrap or jQuery, I would probably be inclined to take 10 marks off of the total, but since it's 100 out of 100 marks to begin with, you can see that overwhelmingly the majority of the marks here are for the PHP components and being able to successfully process the AJAX request. Although even then, you can see the AJAX request is like 10 out of 100, but like the PHP chain is worth 70% of the grade in this one. So it's a PHP assignment with some other stuff stuck on the side. Does that make sense? If you're having difficulty meeting the deadline, I highly recommend prioritizing the higher ranked categories. Sound good? Any questions? good, good. Wonderful. So it goes. And I haven't forgotten about the assignment for.
Well, I'm not there yet, don't worry.
Yeah. I figured we'd probably have some time. I didn't want to bother Kevin about it on break week. But also because, I got to dig around it a little bit in there first. See if I can't find it for myself. So, SQL. Now, I would say something about, oh my gosh, we're doing yet another new programming language, but, I made it very clear at the beginning of the course that this is what the course was going to be like. Hopefully, anyway. Incidentally, we will be back to more, integrating more of the PHP stuff a bit later. But SQL will also require our PHP. That's just, that's how we're going to access SQL. But I will show you some tricks if you want to just play with SQL itself. I'll show you a way of doing that without having to go through PHP in the server. So, all right. SQL. In this case, we're talking about MySQL. So, a couple of things to understand about SQL right off the bat. Number one, we are stepping into an older language right here, right now. The way that SQL works is pretty old school. There's a lot of command line interface type stuff that people try to avoid, but it's kind of inevitably there. Fundamentally, the way that we are going to interact with SQL in PHP is to trick PHP into becoming a command line interface for SQL. But don't worry about that. There will be plenty of example code to follow. SQL is a bit of an older language, but it's still very, very much used throughout the internet. As databasing languages go, you have two main camps, right? The first camp is what you call relational databases. The relational database is reasonably similar to an Excel spreadsheet. The data is organized into tables and rows and columns, although in SQL we don't call them rows and columns. We call them records or entries as the rows and attributes as the columns. So we'll see how, once we start getting some tables up, that'll make a lot of sense. The opposing technologies are so-called NoSQL databases or non-relational databases. So you can tell how prevalent SQL is, either MySQL or any of its variants. You can tell how prominent it is in the market by the fact that everything that's not SQL is in its own category, right? But many of the non-SQL databases, such as MongoDB, are JSON based. So rather than having the sort of rectangular, tables and rows and columns organization, which is SQL, it will have kind of like the JavaScript object, embedded arrays inside of dictionaries kind of feel to it, which, is good as far as it goes. Many social media platforms, for instance, the main databases that they use are more JSON based. JSON's a little bit more flexible, it's okay, but if you want, the more institutional style databases, you are certainly back in SQL land. Banks use SQL primarily. Login systems use SQL primarily. I'm not 100% sure about this, but I would imagine patient record databases would also be SQL databases. So SQL is a very, basically, if you're working for a tech company, you might not be using SQL, but if you're working for anybody else, you're probably going to be using SQL, because most of the databases you'll be working with were established decades ago, right? But anyway, so MySQL is the most popular open source database, period. You guys know what open source means? Maybe? You're nodding. You guys know what open source is? Yeah? Okay, good. So MySQL is open source and free to use, so it's FOSS. Essentially ubiquitous in web hosting packages, maintained by Oracle. You guys know who Oracle, what the company Oracle? Let's bring up. This is Oracle. Get out of here. Go. So Oracle, right? They're most, like, a lot of stuff has gone cloud these days, but for example, Oracle maintains Java, right? So reasonably important company, right? Or at least they're one of the major providers of Java, the Java VM, Java compiler. I forget if they were one of the original developers or if that was Sun Microsystems or if Sun Microsystems became Oracle. I'm not sure. I'd have to check. But anyway, MySQL is fast, efficient, and functions with standard SQL syntax. All right. Used by many large, high-profile web apps, including Facebook, Google, Twitter, and YouTube, just to name a few, plus many, 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 many others. So this is how software worked in the age when SQL came into existence. A company would develop a specification for a programming language, right? So I don't know who particularly, it might have been Sun Microsystems or somebody, made a specification for SQL, and then they would license the specification to other companies to develop the compiler, right? So this is also how the C programming language came into existence. So the SQL specification says your language must contain X, Y, and Z as features, otherwise it's not SQL, right? That's why you have umpteen gazillion different implementations of SQL. They're all done by different companies, but they are seeking to implement the same specification. Question?
Yes. What happened to Microsoft Access in this entire process? Is this viewed as a superior databasing format, or did MS Access just go the way of the dodo as this grew?
So
Its Access was probably first, yes? Maybe?
when did it come into existence? That's a good question.
It's pretty old.
So
92?
92. Oh, okay.
And is there some benefits to?
SQL goes back to 74.
Okay.
So access, so you have to kind of understand what Microsoft does as a company. They don't really invent their own stuff. A smaller company does something, they acquire it, make it a Microsoft product. That's how they got Excel, that's how they got PowerPoint. Access, so yes and no. Like, the problem with databases, right, is that it really is strongly a back-end concern, right? If you're taking raw database output and presenting it to an end user, you're doing something wrong, right? So MS Access, I've never actually personally used it, but you know, you kind of need a server, you know? Like, it provides you a window into a server, or into an SQL database somewhere on the internet, right? Or it can do it locally. But honestly, there's really not much point in local databases aside from learning how a database works and practicing your SQL commands. Yeah, the problem, you note that MS Access has kind of been falling away in terms of popularity, right? This is likely due to the rise of REST APIs and just the much greater fluency of web databases versus this approach. You don't really need this whole big bloated desktop application to do databasing work. You can literally just log into a website and enter data that way, and that's, this is overkill and not, I don't know. I'm sure a Microsoft representative or someone who really, really, really likes Microsoft would be able to tell you why Access is the best cheese that's ever been made by human people. But yeah,
SQL's the thing.
So you can think of it this way, right? SQL is the language of in which the queries are implemented, right? But the software that surrounds those queries, that's vendor dependent. Access is, of course, Microsoft's SQL interface. But many other things have their own SQL interfaces. They're not that hard to set up. And we will set one up using XAMPP in this very class. Does that make sense? No trouble. Good questions. So that's kind of, so you'll notice that there are just a large number of different SQL packages or pieces of software. We will be learning MySQL because it's very popular and open source and very good. But you also have, Postgres, which is a SQL database. you have SQLite, you have, oh man, there's just like a large number of them. The important point is, if you know how to program SQL queries in one system, you basically know how to program them in all systems. Because all are referring back to the single common SQL specification, the sort of basic command set is absolutely constant across all of these platforms, which is good. Yes. So you might ask yourself then, why do they have all of these different things? Basically, the SQL specification is a bit loose. So there's room for interpretation on how things are implemented. So, a company can have a better database just by their database being faster because they're better at programming algorithms, something like that. But often, because it's all marketing, right, it's about the included features, right? You've got basic versions of SQL that are sort of minimally featured and stick close to the specification. You've got, versions of SQL that are attempting to be an MS Office product, see Access. You've got versions that include all kinds of ways of encoding data inside of the database itself that's perhaps not in the specification, but they're like, this is useful, so we're doing it this way. All of this kind of stuff. That's the reason for the multiplicity of different SQL environments. So, if you remember, we said at the beginning of this course that we were going to learn the LAMP stack. LAMP is Linux, Apache, MySQL, PHP, Python, or Perl, but we're doing PHP. So the M in LAMP is MySQL. Given the course so far, you may be forgiven for thinking that having a database is kind of like an optional thing, but once you are programming real websites that are not just like, your local Heritage Foundation's website about their cool trains or something, once you're talking about like real business or institutional stuff, you're going to need a database. There's no two ways about it. So MySQL is included in XAMPP and other localhost web server environments like WAMP, MAMP, etc. So, it says refresher, but I'm pretty sure you guys have never seen SQL before in your lives. Am I right? Good. So, what does SQL stand for? And for the record, it is not pronounced squirrel. That is not how it's pronounced. Some people pronounce it squirrel, and they're wrong. SQL stands for Structured Query Language. So, the fundamental thing that you are doing in SQL is you are writing queries. You are setting up a query, sending it to the database, and the database processes your query. Now, when we say query, it kind of implies that you're asking a question, but that's what you're doing a lot of the time. But some of the time you will be sending data to the database to be stored. This is also called a query, for whatever reason. So, SQL allows us to query databases for records, insert records, delete records, and update records. These are your basic operations. Aside from this, you have various setup operations, which we will necessarily have to go through. But this set of basic database operations, these are like your core operations that you as the programmer will work with the most. Probably 99% of all of the queries that you write will be one of these four operations. They are collected into the CRUD acronym. So when I say CRUD operations, what I'm talking about is basic database operations. Create, read, update, or destroy. Web applications are sometimes referred to as CRUD applications. Not because they're cruddy, but because they're often just implementations of these operations on a database. SQL also allows us to create and delete data tables themselves, which is useful. So, all right, let's consider for a moment something like X, the platform formerly known as Twitter, right? So if we think about X, what is X?
Absolute garbage.
I mean, absolute garbage is what it contains, right? But how does it serve this garbage to you? Right? So basically, all right? I don't know what the verb is supposed to be anymore. Do you tweet X's?
I don't.
You know? I'm just going to use the old terminology because it makes more sense grammatically. So, when you tweet a tweet, what are you doing? You are doing nothing more than inserting a record into a database. That's it, actually. When you are viewing your feed, what are you doing? You are viewing a database query. You are viewing the contents of the database sorted by date, sorted by time and date of upload, filtered for people you're following. Right? And that's it. That's actually it. That's all that Twitter is. In my PHP class, we actually made a facsimile of Twitter in class. The code for it is really not that complicated, actually. I always tell my students, listen, Twitter is not that scary. It's just a database. It's the people on Twitter. That's the problem. Humans are always the problem. So, when you like a tweet or you retweet a tweet, what you're doing is you're updating that record. So when you click on the like button, right, every record that contains a tweet will have a column for number of people who've liked this element or liked this post, right? When you click like, it sends a query to the database asking the database to increment that item, and that's all it's doing. It's just doing that and then sending you the updated results, right? It queries every half second or whatever, just like the tic-tac-toe game that I showed you guys. It's just running that query on the database so that you get like the updated likes feed, right? It's really not that complicated. When Elon Musk bought Twitter and fired 80% of the people who worked there, that was correct, because it's really not that complicated. Like, it's seriously really not that complicated. So, consider tabular data. SQL databases are designed to contain tabular data. We have columns which always give you the field, rows or records which always give you the particular data entries, right? So in theory, in Excel, you can flip it, right? So that you have your categories going horizontal, vertically, and then your actual entries are like vertical. But here, you know, it's always rows go across and categories are at the top, right? Now, you won't see this unless you're using some kind of interface for the database that shows it to you. I'd like to show you a command line tool called SQLite, in which you can practice SQL commands without having to run them through PHP, which is a bit complicated, right? But let's finish this let's finish a few things, and then we'll get there. We should at least see some operations on the screen, right? So this is a column. These are the column names. This is a record. This is a field in a record. This is the official terminology. We sometimes also call columns attributes. Making sense? So far it's not too bad, right? So, in SQL, you have 4 keywords that correspond to the 4 CRUD operations that we were talking about previously. So, select is for reading records out of the database. Insert is for creating the records in the database. Update is for modifying records in the database. And delete does what it says on the box. But of course, if we were to delete, we can't just say delete. We must specify delete what from what. So at this point, I would like everybody to follow along on your browser and download some software. It's a quick download. Google SQLite. So getting a database hooked up with a server is a bit of a task. It's a bit complicated. We're certainly going to be doing that, but just to introduce these operations to you, I want you to see what SQL is in like its essential form, right? And SQLite is the essential form of a database with no bells and whistles, with no like fancy advanced features, right? So, please go to the Download tab. Scroll down, you'll get pre-compiled binaries for Windows, assuming you are on Windows. If you're on a Mac, download the version for Mac. People who aren't here right now. So, what you'll want is SQLite Tools, WinX64. There you go. Just save that up. Open your File Explorer and unzip that. Extract the archive. You will see that you get 3 programs. SQLDiff, which is a differencing program. It tells you the difference between 2 programs. SQLite3, that is the one we're going to run, and SQLite3 Analyzer, which is also not what we're interested in. So, double click on SQLite3. Okay. So, in this dialog, Windows protected your PC. If you click on the more information, then you get the run anyway button. So please run it anyway. Ba-boom. So, ooh, I can increase the font. Lovely. There we go. All right. So, this is the command line interface to SQLite. If you are working in a Unix or Linux environment and you want to do things in Bash, you know, things can run reasonably similarly. You would just like need the name of the program you are sending the query to as like the first thing on the line, and then you can send queries, right? But anyway, so let's do a little bit of setup first before we can actually write some queries. We have to open a file. So .open, and then you pick a file name. For example, patients.db. Databases usually have the .db file extension. Press enter, and now you will see in our folder, patients.db database file has been created. So far, so good. Now, the next thing we need to do is we need to create a table. So, create table patients. Oh. Man. Give me a second. What is it again? Oh yeah, okay. So, when we create a table in SQL, that we must know what the columns of that table are. We can't just create a blank table. So, let's imagine that we wanted to create a table with a text field for name, a integer field for age, and text field for ailment, something like that. Sorry, I'm still in Java land where the data types go first. There we go. Create table patients. Name is text, age is integer, ailment is text. This didn't give an error, so we can assume the operation was completed successfully. If you type .tables, that shows you all of the tables that are in the current database. So a database can contain many tables, just as an Excel file can contain many individual spreadsheets. Right? Does that make sense? You can even cross-reference tables from other tables, but that's kind of more advanced SQL stuff. Let's just get the basics working. So, having a patient table, let's add a patient to it. Insert into patients values Nick, age 36, ailment is butt fall off disease. All statements in SQL must be semicolon terminated. Yeah. Oh, okay. So it's expecting single quotes, that's the problem. How silly. So, insert into patients values, Nick 36, butt fall off disease. That record, that entry, has now been stored in the database. In order to see it, we have to perform another query which reads the database. Database reading operations are called select queries. So, select, let's just do star for now, from, and then the table name, patients. Always forget this stuff. And you can see it returns the entry in the database. So far so good, but there's only so much we can do with one record in the database, so let's add a few more records into the database. Felix is 2. He has 1, and she has teething, which I think counts as an ailment. There we go. Now, if we take a look at the contents of the database, you'll see, bing, bang, boom. Is this making sense so far? It's not too bad, right? It gets a bit more complicated, of course. So, for example, filtering. So, let's say I'm not interested in getting all of the patient database records. Perhaps I want to filter this output for only those people who are younger than 18, for example. You say, select star from patients where is the filtering keyword? Age is less than or equal to 18. And there you have it. So the where clause allows you to enter Boolean conditions the same way that you've been entering Boolean conditions in if statements and loops for some time now. The syntax is almost exactly the same. So what it does, it goes through the whole database, running this for each entry. If it comes out true, it adds it to the output. If it comes out false, it doesn't. And that's filtering. Does that make sense? You can also do it like something more specific. But here's the thing about SQL. It uses single equals for equality. SQL doesn't really have an assignment operation, right? The insert command is assignment in a sense. So, there's no need to draw a distinction between double equals and single equals and triple equals even in SQL. So just one equals means equality comparison. Though two equal signs does also work to the same effect. So far so good? So let's talk about the asterisk. The asterisk here, this part of the query, allows us to specify which columns from the database we want to see. It's probably the case that you don't always want to see the whole database. For one thing, the database can be very large, right? For another, it could be a privacy concern or something like that. So, you can select which columns you are viewing here. So let's say we just want to see name and ailment, because we're not interested in the age of the patients. Might be tried it both ways. It likes a space after the comma. What did I do differently? Oh, I misspelled ailment. That will do it. So yeah. So selecting only name and ailment, I get the age category excluded. Make sense? So that's actually, those are the basics of inserting and selecting. There are a couple of things that, a couple of additional problems. So, let me just add one more thing to here. So let's say, just for the sake of interest, we have a person with nothing wrong with them, but we want to add them to the database entry. Anyway, so basically the ailments column would be blank, would be null, it wouldn't contain any data, right? If we try to do that, here, for example, and I'm going to not put my wife's age on the internet either, because it seems rude. If we try to enter the data in with an incomplete record here, we get an error. Table patients has 3 columns, but 1 values were supplied. And unlike some of the previous syntax errors I had on the board, this is an actual error that's correct. What you have to do is you have to specify which columns the data apply to. So this is a name, so we have to specify that it is a name, and now it is entered into the database correctly. If we view the contents, you will see we have our 4th entry, both age and ailment are blank. In the database itself, these are being stored as null values. Does this make sense? Good. So, I know we haven't done the PHP or the XAMPP stack stuff yet, but I really wanted to show you guys this tool because this can be used to play around with a database without having to worry about, is my website working, right? So it makes sense to be able to separate those concerns. And so that's why I wanted to show those to you guys. Good. So, now, let's discuss an update operation, right? So, update operations allow you to change the state of records in the database. But if you just, so updating also requires filtering. Filtering in the sense that you're using a where clause with a Boolean expression. If you don't use that, some of these operations can be quite destructive to the data. So for example, let's say it becomes known that Allie is pregnant. Pregnant is not an ailment, but it is important medical information. So, update, I don't know how to look it up before there we go. So, update, we then give the table name, update patients, set, and then you set this, that, and the other. So if we say set ailment to pregnant, probably not what we wanted, right? Because we didn't say which, for which rows we want to set ailment to pregnant, it decided to do all of them, right? So, let's just set that to empty, because that's just silly. And now we add the filtering where condition. Where name is equal to Alan. Oh, it wants the single quotes again. Must be a version thing. Because last time I used SQLite, it didn't care about that. And there you can see we have just the one entry that we intended to change has been changed. The rest of them remain the same. Make sense? So the idea of filtering is very, very important in SQL databases. The only operation that you are not performing a filter with is the insert operation. With select, you have the option of using a filter. With update, you absolutely should be using a filter. And with the next one, delete, you also absolutely should be using a filter. If you don't use a filter with delete, then it will delete everything, right? So delete from patients where age is greater than 5. You can see that I have been deleted from the database, but nobody else has. Notice the interaction of that condition with the where clause. Or, sorry, not, with the null value. The interaction of the where clause with the null value. You know, my wife is an adult and should have fallen under that filter, but of course, because the database doesn't know her age, it cannot delete her because of her age, right? Make sense? This is making sense, right? This isn't too bad, hopefully. Good. So, I want you to firmly place in your mind, this is how the database looks, this is how it feels, this is how it works. It is a command line interaction, right? Quite soon, once I've sort of cleaned up the slides that we've just gone over, we'll be getting into how to get PHP to do this. But the way that PHP does this is basically every time I have entered something in, there's a PHP function which does that, but it takes the same query as a string. Anytime data has been output here, data is returned to the PHP script, and then the PHP script has the option of like echoing it back to the end, to the front end, or what have you. So, all of that, I'm good.
Dr. Miller, I have a question.
Yes?
What
Yes, text is just the, text is literally just string for SQL.
Only characters or character and number?
Oh, character and number. Yeah. Well, I mean, technically speaking, numbers are characters as well as alphabetic characters. So yes,
For example, address.
alphanumeric is good. Yes.
So alphanumeric is another type of data type.
No, it's a type of character. So, all right. So you have and then you have, right? You have these categories of characters, right? These are called the numeric characters. These are called the alphabetic characters. These are generally called the special characters. Right? This set here, alphanumeric. And then all of these I'll throw one more category in here, which includes new line, tab, space, line feed. These are white space characters. And then all of these are called characters. Does this make sense?
So where is text is only alphabet?
Characters.
Text is also character.
Yes, text is, even though you wouldn't think so, but here, I'll prove it to you. Because you should never just take my word for it.
But in some sites it says var character.
Varchar, yeah.
Varchar, what is it?
I'll talk about that. Just let me. So ABC, 1, 2, 3. Exclamation point. Space, space. Yes. That worked. And there you have it. So text is just characters. That makes it the same thing as a string. So let's take, for example, so let's talk very briefly about varchars, since it's come up. Should be, yeah, some varchars, right? So, essentially it's the same thing as text, except the number of characters is limited. And like there's a hard cap, a limit put on the number of characters that a varchar can contain, and it's given. And that's essentially the only difference.
So if there is no limitation of the number of character, then I can say just a char, not a varchar.
If there's no limitation on the number of characters, it's text. If there is a limitation on the number of characters, it's varchar. Make sense? Cool. I think I'm gonna I'm just gonna, for the purposes of the recording, I'm just gonna put what I put on that board. There. That's the sets of characters and what they're called. numeric, alphabetic, special, white space. Alphanumeric is both numeric or alphabetic, and they are all characters. So, there you go. When I was at the university, I would have a TA that would do this for me, which was nice. So, good.
I have one more question.
Of course.
We practiced creating a table with just only 3 fields. But what if there is a lot of fields and then there is some error to type input the values? Is there any way to? It means that do I have to remember all the order of fields?
You don't, so you can, but you do have to remember the names or write the names down or be able to reference what the names of each of the columns are. That you do need to have to be able, you do have to do, you need that information. To program with SQL, you need that information. And you will need that information in PHP as well. You don't necessarily need to remember ordering so long as you know the names. If you provide the names out of order,
So what I mean is there only way to insert the values of each field to typing or any other way to insert values? Kind of batch file or?
So you absolutely can write scripts to do this for you. But you're talking about string splicing at this point. So you know, I know all of you are doing this this course with Bash scripting at the moment, right? So in Bash, what you might do is you might say, where's the flash marker? There it is. You could say something like, you know, MySQL with the query insert fill in the blank, right? And then your bash variables integrated in, right? Name, age, etc. And then my database, right? This is kind of what it would look like as a bash invocation, right? You would compose the string, the query string, by inserting values into it, right? These values could be bash variables that are taken from, you know, a command line interaction, or you can bring them, you can read them from files, or, you know, they come from wherever you want, right? You can compose that string automatically, send it to the database, and that's how you can interact with the database that way. Now, that requires programming work, right? So basically, you are either doing manual data entry or you are doing programming work, right? There's no in between there, right? If you're using something like MS Access, it will, you know, something with a reasonable amount of support behind it. You might have features like being able to load CSV files into databases, right? There will be some amount of like fixed operations that like it can perform, that knows how to do. CSV file is kind of like the obvious go-to. Let's see here. But as sort of a general matter, you are either typing these commands in yourself, or you are teaching a computer how to create them, right? Now, the approach that we're going to be taking with PHP is we are going to be teaching the computer how to create them, right? The approach we are taking, I've said more than once, I hope, that PHP thinks of itself a little bit like Bash thinks of itself, right? Something like this is actually directly usable PHP syntax, but it should never be done in PHP for any reason, because it leaves you vulnerable to a thing called the SQL injection attack. I'm going to teach you the correct and safe method of integrating information into a database. But I don't know. You guys wanna see how an SQL injection attack happens? Because I'm like right there. I can explain it to you like in brief terms. You want that? It's kind of interesting. So the SQL injection attack is like far and away the most damaging form of attack and the most profitable for the hacker, right? If a hacker manages to steal credentials from one user via someone's contaminated link, right, in an email. We talked about that process, right? Using that process, you get like what, maybe a couple of people, right? If you can crack the database, you get everybody's information, right? And because not everybody protects their database as well as they should, and because people often reuse their passwords between different websites, basically all of these cracked database passwords that are found on the internet, they can be used to attempt logins on other other unrelated sites, and it's pretty nasty. But anyway, so let's create a different SQL query than this one. Let's say you are doing something relatively simple. Select star from, I don't know, patients, where, ailment is equal to something, right?
Or just a quick question before you go further.
Yes.
If a company has a database called Patients, how is the bad user interfacing with their database? How are they able to have a command line interface that interfaces with the patient database?
They can't access, so
How is it that the client is even attempting to interface with that database?
So, a couple of ways. Number one, your database server might be separate from your web server, like on a different machine, connected through the internet, even located somewhere else. So if that's the case, right, you have client, you have server, and now you have database. Client communicates with server, server communicates back and forth with database, server sends back to client. This thing expects packets which are not HTTP packets, but SQL packets. So it's got its own packet protocol, right? So these are HTTP, S, and this will be SQL packets. Because of the way that the internet works, the database receiving SQL packets doesn't know where those packets are coming from, really, right? It could be coming from a server, it could be coming from a client. There's a validation step. In establishing the database connection, you need login credentials for the database itself. So one of the things we're going to be doing in PHP is we are going to be giving our script login and passwords for this guy in order to be able to log into it. If this is known to the client can access the database directly, get exactly that command line interface that you're talking about. But this is not the most common way that things are hacked into. It depends on a PHP script. It depends on a PHP script losing that very, very, very highly sensitive information to someone outside the company. Now it could happen if it were, for example, a case of industrial espionage, right? Somebody gets behind your wall into your server, maybe one of your employees, and sneaks your server's login credentials to some other third party because they're being paid for it. Something like that could happen. It's more rare, right? Overwhelmingly, and that's also not an SQL injection attack, right? That's just like straightforward, I got your password type stuff, right? The SQL injection attack is much sneakier. I'm going to erase this, okay? The SQL injection attack can be performed through any standard web form, right? So, let's imagine we have a web form, right? Let's say that the purpose of this, it's like an interface for, a nurse or something to look up all of the patients in the system who have a particular ailment. Make sense? So, little text box and a submit button. Let's imagine that the contents of this text box are grabbed from the HTML page, sent to the PHP script. We've already talked about how that works, so we don't have to redo it now. Let's imagine that this ends up up here, stored in a variable called X, right? Or X is probably a bad name. Let's call it search, right? So, and I know I just lost because that's all caps and this isn't, whatever. It wouldn't compile, but I'll still make my point. Fine, do it the right way. All lowercase. That's conventional in PHP. There we go. All right. So, in PHP, whatever is in this string, when you do this, gets spliced directly here with no questions asked, right? So the question is, what is the contents of search? And can we provide contents for search such that we can get different data than the data the system wanted to give us? And can we get privileges beyond that, right? So, it all depends on the contents of search. Let's imagine search is equal to some ailment. For example, give me an ailment.
Headache.
Headache, sure. How this gets spliced in, ailment is equal to headache. Oh, you have to put like the single quotes around it as well. There. Head, ache. There you go. Right? Normal case, normal operation, that will work. The data will be returned, everything's functioning normally. Let's start the hacking, right? Let's imagine that the search term, instead of just being a simple string like this, starts to contain some programming characters. Let's say it is equal to dummy quote or x is equal to x with the final single quote left off. So, what do we get when we splice that in? We get ailment is equal to dummy single quote, right? This, or maybe I should use a different color. I'll use a different color for the spliced in stuff, okay? Dummy quote or x is equal to x. Then we're back to the regular string, like that. So, the whole point of this operation was that we would get only those people with a particular ailment. When is x equals x true? How often is something equal to itself? It's not a trick question. Never? When is 1 equal to 1? Always. Yes. So, this statement, I'll do this in red. This half here is always equal to true. Always equal to true. What's anything or true? Always true. So this, whether it's this part, whether it's true or false, doesn't matter. You're always returning true. Which means you are always getting the entire contents of the table. Right? Because when this phrase is true, it adds contents to the output. So, because this overall is always true, this program, or this interface, which was intended to only allow the user to view people with one specific type of ailment, views everyone in the database, regardless what their ailment is. This is a data breach. This is the exposure of more data than the than the user should have been able to get, and is therefore bad. So, yes?
When you're entering in the search,
Yeah.
does it not interpret that as a comparator to the database? Like how is it going from this true false type of thing?
Mhm.
How does the interface go from true comparing to the database, and then it brings the entire database through?
Well, if we like move these ellipses out a little bit, right? You've got you've got a select statement, but a select statement by default, if you don't specify a where clause, will return the whole database, right? That is the same functionality as where true, right? So if this evaluates to true, it returns the whole database. And on the front end of that, literally, if you take this string, enter it into that field and press submit, in the absence of any checking, this is what happens. Does that make sense? Sort of? Did I answer your question? So that's bad, but it gets worse. So let's imagine that we had a hacker who was not just evil, but had pointy teeth to show how evil they are. All right? What would this person do? And little devil ones. SQL has a comment character. And it has a line termination character. You can actually send more than one query in one string if it's been configured to do that. So, for example, just something, right? You want this to be syntactically correct, otherwise you'll trip a syntax error and you won't get your hack. So it has to be syntactically correct.
So which one is correct, the double quotation mark or single quotation mark?
Both. That's like the single quotation mark here is intended to end this one.
Okay. What about the first double quotation mark?
That's designating the start of the string in like PHP in the language. So yeah, it is actually correct to have both of the different types. It'll make more sense once I splice it together. You know, let's just say that this person was extremely destructive and wanted to do something like drop table patients. So, this is your line ending or your statement ending character. 2 dashes is your comment character. So let's splice this together and see what we get. Where ailment is equal to opening quote. See, this opening single quote is here, right? Next, we start splicing in the string. We start with the first character of the string, which is G, not the double quote, of course. G G. That closing single quote close, notice how that closes it, right? End statement. Drop table patients. End statement, comment character, and then the rest of the string, which is ending single quote, semicolon. So the comment character means that the rest of this is comment, which means it's not executed. So you can, whatever the rest of this statement was, it's thrown away, right? This, syntactically and correctly, ends the statement. This will return nothing, probably, unless a valid ailment were entered here, which it probably wasn't, right? So that statement ends unsuccessfully. If the server has been configured to accept more than one statement at a time, which for programming purposes can be very convenient to do, it will just execute that. And does anybody want to care to guess what drop table patients will do to the database?
It's gone.
It's gonzo. And depending on how you've configured your backups, you know, when you try to recover that data, first of all, you might not have a backup if you didn't configure backups, so your data is just gone. There is no undo in SQL. If your database is configured to update nightly, then you've lost an entire day's worth of database entries. If it's configured to back itself up hourly, then you've lost an hour's worth of database entries. You know, so this can be extremely destructive. You can execute arbitrary things. This is the nuclear option. But there are plenty of other things you can do too. Jumping away from like patient databases, let's talk about web design again. All right. So what you can do as well, you know how the whole point of the XSS attack was to get a malicious JavaScript to run, right, by inserting a script tag? This can be an insert operation. If any elements in the database are being reflected into the web page without being checked first, you can also, like if your database gets cracked, someone can insert a malicious script tag into your own database, and then your own database can send that malicious script out to whoever loads a page. And that is even, like that's so much worse than the email scam link. Because with the email scam link, you yourself have to perform an action to get hacked, right? You have to click the bad link. And if you're sufficiently aware and you're not like, 70 or 80 years old and that sort of thing, clicking the bad link is something you can avoid doing to prevent getting hacked. If somebody has hacked into the database and left a little present for you there, it doesn't matter, there's no degree of like your behavioral things you can change to prevent getting hacked from that by that. There's nothing you can do. If you load the web page, it will load the malicious JavaScript, and you will suffer the consequences, right? And like the website will look normal. You didn't click anything suspicious. It's just the regular website that you've been using for like 10 years, and suddenly it contains malicious script and you've been hacked. And the reason is somebody left a little present in the database for you using an SQL injection attack. Although if you have that level of access to the database, you probably don't need the client to give you the information at that point, right? You can just do it. Any information they have, you just have access to in the database. But the point of this is, all of this can be done from a text box, right? All of this can be done from a text box, so unless we are properly protecting against this type of attack, one could be desperately up a particular creek without a paddle, let's say. And this is another place where, like, PHP is a language where you can know just enough to get yourself into a lot of trouble, you know? Because this is the natural way to do things in PHP. It's also the natural way to do things in bash scripting. But because PHP allows this, PHP is credited as the language which invented the SQL injection attack. So, any questions? No? Okay. All right, it's 11 o'clock, so I think we will have our 20-minute break. When we return, we will actually get into XAMPP and show how that gets set up, etc. Sound good? Okay. All right, in 20 minutes then. And we're back. I feel like the picture should be coming through. How did that even happen? I didn't touch it. Oh, maybe I did. Maybe I did when I brushed it when I plugged the thing. Okay. All right, we're back. So, I'm going to assume that we have a reasonable handle on our basic CRUD operations at this point, and that from now on we are primarily focusing on how to get these things set up on a web server. Cool? Sound good? So, once again, everything comes back to a command line tool. In the case of MySQL, there is MySQL, a command line program from which you can execute SQL queries. Again, in a bash or bash-like environment, you can just do this. You can just formulate your query, send it to MySQL, and Bob's your uncle. But, of course, we are interested in a web interface for this. So, PHP MyAdmin gives a graphical user interface for modifying tables and records. PHP MyAdmin is included in XAMPP and many standard web hosting packages along with MySQL. So, let us access PHP MyAdmin. First, let's open up Mohawk Apps. No, I don't actually have to do that one. please launch XAMPP.
Are we recording? Yes.
Yes, we are. Man, everything improved so much when I figured out that I could like flip the thing around so I could watch the recording as it's recording. I don't have to walk back there to see if it's recording. Yeah. All right, so XAMPP control panel. We now want to initialize not only our Apache web server, but our MySQL server as well. Start both. Two greens, there we go. Don't worry about that. So, under MySQL, SQL, you have an admin button. If you click that, it brings you to localhost 1080/php myadmin. Binga banga boom. So, this is PHP myadmin. All of the operations that we performed through SQLite can be performed here as well with a clickable user interface, which might be a little bit easier. It's very important to understand, though, in the back end, something very like SQLite is running. All of this is just an interface to it. That's what's actually doing the processing in the background. So, if we wish to create a new database, okay, let me back up. You'll see that we have some databases already here. These are not to be confused with tables. Tables are a different thing. These are databases. In our previous example, these would be different database files, right? So, we wish to create a new database. New database, database name, let's say, I don't know. I don't want 3 things named patients, you know? Let's say,
Hospital.
yes, my hospital. Create. Don't worry that it looks like you're making it in Latin Swedish. Latin Swedish does not exist. Just leave it as the default. Everything will work. Trust me. So, once we have created that, you will see my hospital appears in the list of created databases, but it currently doesn't contain anything. Contains nothing. So, we are automatically brought to the create table dialog. So, let's create a table. We did patients already. What's another thing we would keep track of in a hospital?
Medications.
Medications. Excellent. Medications. Click go. We are now provided with a highly complicated interface, but don't worry, most of these columns we don't have to worry about. So, let's say we want to create medications with an identification number, a name, text, perhaps a stock in, make that a double, and oh, I don't know, what else would you need?
Is narcotic.
Sure. Is narcotic. Boolean. There we go. We save that. There we go. And you'll know, oh, let's see here. So we now have our medications database. You'll see that we have a table with nothing in it. So far so good, right? A little bit faster than last time, right? Now, it is possible to perform all of our SQL queries through this interface, but the whole point of having a web app is that you have something that looks nicer than this that the end user would want to use, right? So if you need to, you can go and fix the data if there's a problem using something like this, right? You can repair tables, you can do that kind of thing. But in general, you know, I'm sure all of you have seen terrible interfaces that you were expected to use. This is probably up there, right? But that's because it's for developers, right? It's not for the end user. It has all of the options that you could possibly ever use. Like all of the options in MySQL are here somewhere. But anyway, you can just you can just type SQL commands into this thing. So if you hit the SQL tab, this allows you to enter SQL strings the same way that we were sending them in a command line via SQLite. So for example, oh, and it also tells you what the column names are, which is very useful. So, insert into table name is medications, values, one, what's the name of the medication?
Tylenol.
Tylenol. Stock, let's say we have 20,000 Tylenol, and is narcotic is false. You can see it'll even help you out with like common forms for certain queries. Right? Like it'll auto-insert this if you use the buttons at the bottom. So, if you click go, does everybody have this still working on it?
1 second. Yep.
Good, good, good. Click go. Row inserted. Go back to browse. There it is. Now it's saving like ones as trues and zeros as falses, but you know, so it goes.
Can you go back?
What did you click?
Go.
No.
It's right here.
Oh. Select. Medication values.
What's another medicine? Anybody? Azithromycin. I probably misspelled it. And then stock, let's say 460.65. is narcotic, false. Executes, there we go. And now we have that too. I know azithromycin because I have to take it instead of penicillin because I'm allergic to penicillin. So yeah, so far so good. This is just the same thing we were doing before, but in a slightly fancier interface that isn't just the command line. But you can see how, like, the only thing this is doing is it's presenting buttons and text fields and running the command line application in the back end, right? Hopefully that's obvious. It's not magic. It's just the programs. All right, so we have a database. This database is connected to our web server. So we can write PHP scripts which interact with it. Yes. So, PHP includes multiple extensions to access MySQL databases, quote unquote, out of the box without any further installation necessary. MySQLi extension, but most importantly, the PDO extension. The PDO extension is the one we are going to be using in the class. If you use it correctly, you will not have a problem with SQL injection attacks. So, PDO stands for PHP Data Object. It allows us to access and modify MySQL databases. That is to say, it allows us to send queries. Unlike MySQLi, it will work for SQL databases that are not MySQL. Like Postgres and other things. MariaDB is another one. So, this is the connection code. I know it's complicated, but we will go through it in sequence. So, we haven't really talked about exception handling, I think, at any point. You guys haven't done exception handling in any other course that I'm not aware of, have you? Okay. So, very roughly, this is what try and catch mean. This is called exception handling. An error might occur when we try to establish the connection, right? For example, let's say our login credentials were incorrect, right? In such a case, this guy here will trip an error, or it will throw an exception. If an exception is thrown inside of a try block, instead of the program crashing, you execute the contents of the catch block instead. So if this thing can't connect to the database for whatever reason, it will instead echo connection failed and then concatenate with whatever error message was sent. Does this make sense so far? Not really? Okay, so let me see if I can think of an analogy. Okay, physical analogy time. An exception, or a runtime error, will, you can think of it like a big bowling ball, all right? When an error occurs, you can think of this ball as being handed off from statement to statement. You take the ball, then you give it to the next statement. If the statement encounters an error, it drops the ball, right? The ball comes crashing down to the ground, and if nothing catches the ball, the program breaks, right? Try says, oh, I don't know, this is a part where the ball might fall. I'm going to set up so that I might be able to catch the ball when it falls. So it's like, this is the zone of awareness of an error. All right? Is this making sense? So, if the error occurs inside of the zone of awareness, it's like there's a big catcher's mitt underneath the ball. So, if this statement drops the ball, the catcher's mitt catches it. But instead of, and that it does that instead of letting it crash to the ground and crash the program. So where does it go from the catcher's mitt? If it's caught in the catcher's mitt does not give it back to the next statement up here. It doesn't continue the normal flow. What it does is it's like, oh, something happened, I'm going to give it to you. And it gives it to this thing. Right? So if it flunks out with an error, it executes whatever is inside of the catch statement. When you are catching an error, do this. Right? Does that make sense? It works a little, sorry?
What is the expression inside of parentheses? Catch?
Here?
Yes.
That is catching a particular type of exception, a PDO exception. So basically you can design the MIT to only catch particular types of exceptions, right? So in this case, it's looking only for a PDO exception. If any other type of exception happened inside that block, it would just also cause the program to fail. For example, you know how zero division is a problem? Right? I told you about that, hopefully. Zero division in a language which supports exceptions will cause an exception. So you can actually handle and recover from those types of errors. It just requires a little bit of foresight. So, anyway, so that's what the try catch does. Any questions? It's a bit like an if statement, except the if condition is, if an error is experienced in here, do that. Cool. So, let's dive a little deeper. Connection is equal to new PDO with 3 parameters given. Now, unfortunately, we are going to have to call our minds back to programming fundamentals and object declarations. The new keyword means that we are declaring a new object of class PDO. So PDO is a class. This creates a new one with these parameters, stores that newly created object to the connection variable. So connection is now a thing with methods that can be called. Does that make sense? Hopefully. So, the whole point of this entire block of code is that this thing should exist afterwards, right? In my opinion, you probably want one more line here, which is like an exit, right? Like if you fail the database connection, you can't really do anything, right? So it's probably correct to exit the program at that point. right? So let's go through these three parameters. The first looks a little bit like a URL, just a smidge. MySQL :post equals serve, database name is equal to database. So this is where you enter in the information about which server you're trying to connect to and what database within that server you want to connect to. Remember that in my PHP admin over here, we have several databases, right? So we need, number one, where that database is, and two, what, okay. I apologize. I should be drawing a better distinction between the database server and an individual database. So, host is the name of the database server. Most of the time this will be localhost, but if your database server is on a different machine to your web server, then that will be an actual proper URL. Database name is the name of the database on that server that you wish to access. We're going to do an example, don't worry. You then require a username and a password for that database in order to connect. So, in XAMPP, it defaults to the following. Your username is root, and your password is blank. It's just an empty string. So, if we set username to root, password to an empty string, in theory, we should be able to connect to our database that we've created using PHP. You want to try? Let's do this.
So the username and password come from the database, not from users.
Yeah,
But
that,
how can I compare the user's username and password from one user and the ones from database?
I'm so glad you asked, because like this does get like, we have to like start, they have the same name but they mean different things. These are your username and password for the database server. That's completely unrelated to any information entered by the user so far, right? We are not even talking about taking user information just yet, right? When the user enters information, you splice it into a query, send it off to the database using the PDO object, but we have to establish the connection first, and that's what we're doing. Does that make sense? Sort of? Hopefully? Let's try it out. See how we do. So, if you wouldn't mind, everyone, please open up htdocs. And also, please open VS Code. XAMPP, htdocs, and your newly created folder. All right, new file. Let's call this readdb.php. So, let us do as all good programmers do. Copy and paste. Messes up your indentation, but otherwise comes out quite well. So, I am personally inclined to add 2 additional variables here. Number 1, database name, and number 2, host name. We can then assign these at the top. Host name, database name, username, password. Just like that. Of course, we'll be, filling these strings. I just wanted it syntactically correct. So, the host name is the location where this script can find the SQL server. Because this is running through XAMPP, the location of the server is the same as the location of, the location of the web server and the location of the SQL server are the same. They're on the same machine. So, in the same way that the browser looks at localhost and sees XAMPP, the web server can look at localhost and see the MySQL server. So, host name is localhost. Boom! Database name. Do you remember what we called it? Nope, that's the table. The database name is My Hospital. I don't really have time, but another thing you could do is you could add patients as a table within My Hospital as well as medications, right? Tables and databases are different ideas. So, we now use the default login credentials for XAMPP, which is root and nothing. We enter root, password is empty, there we go. Now, let us load this PHP script and see if we can't get a connection successful message. So, we want localhost 2024-02-7. There you go. This is the PHP script that we just wrote. Read DB. What do we get when we click on it. Connected successfully! Now, here's a, just to prove that this is actually working. Let's imagine that we messed up our login credentials. Instead of saying root, we said schmoot, for example. In that case, when we try to connect to the database, we get connection failed. SQL state, access denied for a user at localhost 2 database, my hospital. It just says you had a login credential error, and it pushes that out. Does that make sense? Normally, you wouldn't echo connection successful like this, because that will be visible to the end user, and that's not information that's useful to the end user. If anything, and there we go. So, what was I saying? Yeah, so connection successful, this is the type of thing that should end up in the console. But you can't print to console directly from PHP, you have to do it through JavaScript. So you could say something like this. Echo script console.log connected successfully. See what I'm doing there? Just dropping a little bit of JavaScript in. Save. Now, well, I have to correct this. Here we go. View the inspector pane console. There we go. All right, reload page. Connected successfully appears in our console instead of on our main page because it's now in a JavaScript tag, so it's being sent through JavaScript. Right? Make sense? That's just a way of avoiding having to do that with, the user seeing it. But anyway, so going back to our script. So, we have established a connection, but we do not know what yet to do with it. What do we do with a connection once established? So, statement is equal to connection, arrow, query. Now remember, PHP uses arrow instead of dot. Where in C# or JavaScript, you would say object.method. In PHP, you say object arrow method. So query is a method provided by the PDO object. We can throw in a query string, like so, and that is our PHP, or that's our SQL query. I know, things are getting a little complicated, right? It's like we are writing SQL queries that must be sent by PHP, which will then be received by PHP again, which will be sent through HTML as JavaScript optional. It's like we literally are using like 3 or 4 languages at once, right? Web technologies are tightly coupled. So, once we've sent the query, the statement object is the return result. So this statement object contains the return result of the query, but we have to use the fetch method to extract it. So let's, again, copy pasta. So, select name from users. If we remember our hospital database, we don't have name and we don't have users, right? Our table name is medications. And one of the fields, let's just say, well, name is actually correct there. Make sense? So, this is kind of weird, and I don't agree with putting it on this slide. Actually, this is performing assignment inside of a while statement, a while loop condition. If you were to expand this, you would say the following. While row does not equal false, and then at the bottom of the loop, you update once again. What do you complain about? Must have mismatched parentheses somewhere. Line 27. Yeah. Let's see. Checking. Did I introduce this in? Ah, I have the opening curly brace twice. That will do it. There we go. So, we get, as an output, Tylenol is azithromycin. So, obviously, you want some spacing in there. So, let's just concatenate with a break statement. You could also, you could do it, well, let's do it slightly fancier. Echo unordered list. List item, concatenate, add, concatenate, and list item, and then echo and UL. Not trying to give people hints about assignment 3 or anything, but here are some hints for assignment 3. Right? You can just pop HTML tags in. So, now, oh, got the wrong slash. There we go. Now all of the medications in our database are given with a very nice bulleted list. Ta-da! So, what's cool about this is if you go into the medication database and you add more data, right? Let's see. ID 3. What's another medicine?
Morphine.
Morphine. It's good. Stop. 9,000.1. And is narcotic?
Yes.
Yes. As a matter of fact, it is. Go. There we go. If we take a look, morphine is now in our database, right? Going back to our page which reads from the database, all we have to do is reload the page. Morphine now appears. The data is being pulled from the database, and it's independent of things which are adding data to the database. Does this make sense?
So technically, you could have a different user adding to the database while you're viewing the output at the same time.
So yes, with an asterisk, all right? The asterisk is you only get new information if you refetch from the database, right? But yes, if this thing has been configured with Ajax, for example, to run that PHP script every half second, right? Then if some user somewhere else sends something, adding something to the database or updating the database, when that Ajax query runs the PHP script and the PHP fetches the new state, sends that back, updates the web interface, basically your list of medicines and quantities, for example, will never be more than 30 seconds out of date. Or more than half of a second out of date. I don't know why I said 30 seconds. Probably because that's half a minute. But anyway, you get what I'm saying, right? So, powerful, powerful stuff, right? Like when you are on the Twitter, when somebody tweets a tweet, it pops into your feed, right? That's because that web page is periodically checking the database to see if it's been updated. And when it does, it loads the new update in automatically. The user is not required to click a specific button to do it. Make sense? Wow. And you know, this could be taken, like right now we're running this as a standalone page, but this could very easily be the return result of an Ajax query, which would then be popped into a div in another page, right? In fact, yeah, I think we have time to do that. You want to see that working? Okay. So let's make a index page, index.html, bing bang boom, boilerplate. Here we go. Let's make a div. There we go. Script. I'm just going to do it here because it's quick. Gotta load jQuery. The jQuery CDN. Minified. Copy. Paste her in. Now we have jQuery. Div's going to have an ID. Medicines. Here we go. What is it? Dot post. I think, for an Ajax query. Yeah, here we are. So, the URL as a string, it's a relative URL. We don't need the full path name, but we need our PHP script name. So that will be readdb.php. Next, we need to send, we need a function which processes the result. You know what, I am going to have to, let's see here. Function receives data. Let's just console.log it for now. See if we can get it returned. And that should, I think, suffice. We'll see. Now, loading the index page. There we go. Yep, there it is. There's our result. Now, I'm going to just quickly go in and delete the script, this bit, or commented it out because, you know, put my exit in there. There we go. So you'll notice when we reload the index page, that is our correct list output. We're just logging into console instead of putting it into the putting it where we want it. So let's go back to our HTML page right here. There we go, callback function. Instead of console logging the data, let's access element name medicines dot text, or no, it'll have to be .html is equal to data. Oh, did I? Like that? Yeah, there it is. Boom. So, you know, post to readdatabase.php, callback function, medicines gets HTML, medicines put the HTML which is received from the database. So you can see we're doing a fairly complicated thing here with not very many lines of code, which is cool because the fewer lines of code there are, the less likely you are to make errors, right? And I know that it's like, okay, we just did so much, right? And what's changed, right? Nothing. But, you know, let me put a div around it, or let me put a border on the div just so that it looks different from the previous one. Style, border, 2 pixels, solid black. There you go. So now it's in a div. Very nice. Well, it was before, now it looks like it's in a div. And now we need to do the stuff where we are periodically updating, right? So, set interval function, this, functions and functions and functions, I know, every 1,000 milliseconds. So now, this AJAX request will be performed every second, if we've done it correctly, but we can always check that by checking out the network tag. There you can see, every second it's reading the database. Now, we don't have an interface for it yet, but let's insert into the database ID for what's another medicine?
Fentanyl. F-E-N-T.
Something like that?
Sure.
Fentanyl? Or I think it is fentanyl.
Yeah, that's what, or phenol would be that.
It doesn't matter. Fentanyl, quantity is 2. Is narcotic is, boy howdy, yes. Alright, now watch this, because I'm about to click go. Here we go. Click go. Boom! That fast. And that, of course, simulates what would happen if somebody sent a like a regular query, right? From a PHP script. Same thing would happen. Cool, right? We're starting to get there. We're starting to get to useful stuff. So let's go through this in a bit more depth, and yeah, let's take a look at the PHP code again. So first, let's examine this statement. Hopefully, this one makes a certain amount of intuitive sense. The connection object that we established above, which is our connection to the database, we call the query method. Pass that the SQL string, and query will send that to the database and execute it. There's a lot of packets being passed around in the back end that we don't have to worry about in this class because this isn't a networking class, right? This is a software class, so we don't have to worry about how the packets are actually being sent. But this sends packets. It's still important to know when packets are being sent. And this sends packets, right? It sends a query as a packet to the database, receives the response back from the database, and stores the result in statement. Really, this is not so very dissimilar. Like, this is quite similar to the type of transactions that the client and the server perform with each other. The client initiates some kind of request. The server serves the request and sends a response packet. In this case, the server is acting as a kind of client, right? The server is sending a request to the database server. The database server is serving that request, sending the response packet back, and it's caught right there. Does that make sense? So, this little guy contains the data that was sent back from the server. the way that we get it out again is by using the fetch statement. The fetch statement gives us all of the contents, or all of the response of that query one line at a time. So there's also fetch all. Fetch all retrieves everything at once. Fetch returns one at a time. You can see, just pulling back in to this analogy, right? This stuff. When I do select star from patients, this is what the database outputs. The fetch method is giving me each of these lines one at a time. When it runs out of lines, it returns false. And I think probably I should be using a stronger equality comparison here. So when the fetch thing, when the fetch method runs out of lines of output to go through, it returns a false value instead. That's what we're using, that's what we're leveraging to control the execution of the loop, which loops over all of the results returned from the database. So row is equal to statement fetch. So row becomes the first entry in the database. In this case, we're selecting all, right? Like, we're not using a filter, so we're selecting all of the different medications. So the first row we get is the Tylenol row, right? The next row that we get is row 2, then row 3, then row 4. Once we try for row 5, we return false. False breaks the loop, and we finish. Does that make sense? After a fashion, hopefully?
So
Question?
if we use fetch all instead of fetch method, then in row variable become array.
Let me show you. Yeah, it does become an array.
Then in this case, do we have to use for each group instead of one?
You can, yeah. That would actually, yeah, that would be a good way of going about it. It's useful to just look at the data raw, so I'm just going to bounce it back to the client as a JSON. Statement, arrow fetch all, there we go. We want to JSON encode that. Bing, bang, boom, and we want to echo that back to the server, or back to the client, pardon me. This is what your output is. You can see that it's an array of objects. Well, an array of objects in JavaScript. PHP has a special fancy term for these. It calls them associative arrays. But it's basically the same thing as a JavaScript object. So we've just got an array of objects, right? Containing, well, actually a little bit more information than I was expecting. There's like a 0 in there for some reason. Not sure what that's all about. But, for example, if we wanted to not just see the name, but also see the, what do we have as fields again? Is narcotic, for instance. You can see that the is narcotic information is now contained inside of this array as well, right? So it's literally taking this information from the database, pulling it into records. Read dictionaries, read associative arrays, read JavaScript objects, collecting them up into a big array, which you can loop over, and then doing what you like with them. So let's modify this to use fetch all. Modify this to put things back the way they were, maybe even a little bit improved. So let's make that rows instead of row. We will need a loop variable, so why don't we just write a for loop here? For I is equal to 0, I is less than count rows, because in PHP it's not rows.length, it's count rows. You know, you just have to memorize that sort of thing. I plus plus. Yeah, I'm starting to get a bad headache.
Weather change?
Must be. They were saying that there were supposed to be thunderstorms this evening. So
This afternoon.
this afternoon.
In February.
Yeah, it's quite strange. So because these things are associative arrays or JavaScript objects, the way that you get stuff out of them is the same way that you can get things out of them in JavaScript. Although in JavaScript you can also use dot notation for this. So row at I at name, or rows at I at name, will give you the name of the current row in the data that's been retrieved from the database. If we want to then say, you know, so in this bit, I've just added a little bit more to the string that, you know, shows us whether or not it's narcotic, right? Save, save, save. And there you go. You'll notice I didn't even have to reload the page, right? That's because the index page was not modified. The index page automatically picks up on any changes that are made to the PHP script without having to do anything itself. Because this thing is just reloading periodically, it reloaded the updated version of the PHP script. And you can see whether or not things are narcotic has been put in. If you want to be a little slightly amount more fancy, you could say, you could put this inside of a ternary statement. Yes. Just to make it a little more readable. Did we do ternary statements? You can see I saved it, there you go. It's already worked. Okay, I'll talk about ternary statements just very shortly, very briefly, because they're useful for that type of thing. It's like an in-place if statement. So, if you put a Boolean expression and then a question mark and then two options, it will evaluate this as a Boolean expression and basically substitute this expression for either the true case or the false case, depending on how this came out. So, you know, the alternative to that is to like make a big if statement that takes up several lines and like, you know, assign either one or the other to the same variable and then put the variable in. This is just a way of doing it in place. Right? A little bit compact, a little bit, you know, nicer to look at. But, you know, the alternative would be like, you know, if is narcotic, print one version, else print other version. This just kind of compacts it down a bit. Any questions? So, yes. So that is a general query. If you are taking input from the user, you need to do something a bit heavier. So let's say that we wanted to create a view of the database where what we are seeing is only those medications whose quantity is considered low, right? But we don't want to make a decision ahead of time about what low means, right? We'll do a hard-coded version, but then we'll do it otherwise. So the problem is, let's just go forward and do it sort of in the regular way, and then I'll show you why this is wrong. So where stock is less than threshold, right? And let's say that we're doing a silly thing, which is we're just reading the threshold variable from the get superglobal or post superglobal without filtering at all. So now we are reading the value of the threshold variable from the included post parameters, assigning that to a threshold variable, splicing that directly in to our query string. This is precisely the thing that I told you not to do. Okay? So, if you're watching this in internet land, don't do this. This is bad. Don't do this. I do not personally, nor does this YouTube channel, take any legal or any other responsibility for what might happen to you if you actually just use this code on your web server. That's your problem. So let's see what happens. In addition to sending it to the server itself, let's actually send some parameters. I'm not going to like set up the HTML form bits. You know, let's just send the parameters. Let's say threshold is equal to, you know, what's meaningful in this case. Let's take a look at the data.
Oh, it's thundering.
Is that the thunder?
That's the thunder.
Kind of sounded like machinery. Okay, I'll take your word for it. Does it? It's hard being in a basement because you can't just like talk it out.
It's wet out there.
Oh yeah, I can sort of see the sky. Let's see. Oh yeah, and I guess who left his umbrella in his car? I think 1,000 is a good threshold. So let's just set it to 1,000. Right? normally you would read this from a form element in the HTML, but let's just skip that for now. We can put it in if we have time at the end. So, going to our document. There you go. You can see that we have only those indicated which need to be restocked. Of course, you know, if that's the purpose of the web page, it would be good to say something like that here, you know. For example, H3 medicines that need to be restocked, right? That way, it gives the impression, you know, if your system is hooked up to, like if your medicine management system is hooked up to an actual server like this, which, like, in theory, like, you can begin to see why digital health, hopefully, you can see, like, start to see what the actual, like, real world implications and applications of this type of technology would be. Like, that's a useful thing to have, you know? Like, let's say, for example, you have an SQL query, right? Update, we're setting stock to, you know, there's a way to do increment and decrement in SQL, but I can't remember it right now. So let's say set stock to 400, where name is equal to Tylenol, right? Execute, boom. Tylenol needs to be restocked, right? So yeah. Any questions about that? Oh, I remember what this was all about. So the purpose there, basically, this is now vulnerable to SQL injection attack. If this contained an SQL injection attack, we'd be done. We'd be done like dinner. So the way to get around that is using the PDO object properly, using prepared statements. So I'll go through this in theory. Given the time, I'm not sure we'll have time for a demonstration. We'll do that on Friday, if that's okay with everybody. So using the prepared PDO statement, instead of calling query directly, you instead call prepare. Prepare expects the same string, but instead of splicing your variables into the string directly, leave question marks. The question mark character. The prepare method scans this string for question marks and says, oh, I expect something there. You then have the execute method, which you provide all of your values to. Actually, I think we will have time to do this. After that, everything works as normal. So by doing this, the execute method is actually checking for bad characters and SQL injection attacks, whereas if you just splice the string in, and that's all it is, it's just a string splice. So all you have to do to upgrade your security, change your query to a prepare, remove this, put a question mark in. Statement dot arrow execute, and provide the value, which was threshold. And there you have it. I'll put the other version into commented so we can flip between the two. So, save. So you'll notice, first of all, no difference, right? The PDO object still works, but let's see what happens if we modify the sent parameter. So, right now we're just sending a number. But what if we send 1,000 or 1 is equal to 1? Save. Refresh. Excuse me. We're still having a class in here.
Sorry.
Kids these days. So, there you go. You'll see that the PDO object is still fine, but if we modify the PHP to use the unsafe version, I hope this works. Well, it's certainly done something, anyway.
So if you will say the 100 where 1 means, so all, 4 medicines will be displayed.
That was what I was going for, yeah.
Right?
Yeah. Like I'm gonna have to Oh! I'm using the wrong method. There we go. So, I was using the wrong method. So, you can see using the SQL injection attack, the entire database has been leaked. Whereas, if we disable that one, put in the safe version is clever enough to not only it not only detects and prevents the attack, it actually corrects the statement to what it should have been. It takes out the or 1 equals 1. Right? So it's doing stuff in the back end. You really should use the PDO object using prepared statements instead of just blasting your queries off. Now, if it's a query that doesn't integrate any user information, it doesn't matter. It only matters in cases where you're trying to splice something into a string. But if you are doing that, you really should be using this method. Does that make sense? Now, there are a couple of different layers at which that could be hot. We are also not filtering here, right? We could modify this so that threshold is filter input post, name is threshold, and it's supposed to be filter validate int, right? And then you would have something like if threshold is equal to false, echo that parameter exit 1 or 0. Right? Something like that. In that case, you can see we get a bad parameter instead of getting the SQL injection attack being handled. Right? Which, I cannot emphasize this enough. The best security is all the security. Right? Multiple layers of security are better than having, fewer. Don't put all your eggs in one basket. Don't put all of your security steps in one method, right? Or in one line of code. The reason I show you all of this security stuff is A, because it actually does matter, right? And B, ideally you would use all of it at the same time. Be as secure as possible, right? Does that make sense? Okay. Well, I think that that's all that we have time for today, so thank you very much for your time and attention today, folks. We will resume on Friday, and we'll do more examples. We didn't quite get all the way through the PDF, but we basically did actually, so. We essentially covered it all, even though well, there you go, we covered it all. I just said it. Next time, we'll do some insert operations from a web interface, so that we get like a full thing going on. Okay? Awesome.